Okay, so here's some more. I said I only had 2 more, but I actually have more than 2 more because, again, they're just so different each time. It's nice to see a bunch of examples. So my next one is this 1 plus cosine x over sine plus sine x over 1 plus cosine x. Okay, first thing we want to do is, in this case, we want a common denominator. I can't do anything with them separate. They're already in sine and cosine, so I actually need to stick them together. So I'm going to times this by sine x over sine x, and I'm going to times this side by 1 plus cosine x. Okay, that should give me a common denominator. So if you notice on this top right here, I'm going to have to FOIL that out. And it might not be very pretty, but that's okay. So 1 plus cosine x plus cosine x plus cosine x squared over sine x plus cosine x sine x. Okay. And you know what? That looks messy. So I'm actually going to leave it as sine x 1 plus cosine x. For some reason, I think I want to leave it separate just in case. If it works out that I need to multiply it together, I will. But until then, I'm going to leave it separate. So plus sine squared x over sine x 1 plus cosine x. Okay, yikes. We could put these together, and we're going to simplify this. So right here we could simplify. So I'd have 1 plus 2 cosine x plus cosine squared x, that should be a squared, plus sine squared x all over sine x 1 plus cosine x. Okay, so there's a lot going on here, but right here, this cosine x plus cosine squared x plus sine squared x is a Pythagorean identity. If we look at that, if you look at your paper, sine squared theta plus cosine squared theta equals 1. So this right here is simply 1. So we now have 1 plus 2 cosine x plus 1. Okay, all over sine x plus, or sine x 1 plus cosine x. So if we look at this further, sorry, running out of space, this is the same thing as 2 plus 2 cosine x. I'm going to take this and I'm going to factor out a 2. So I'm going to have 2, 1 plus cosine x all over sine, you cannot see that, all over sine x 1 plus cosine x. Well, I can now simplify this out. So I have 2 over sine x. Well, that's the same thing as 2 times 1 over sine x, right? That's like 2 over 1. I haven't changed it. I'm just looking at a different way to look at it. Well, I know 1 over sine x is 2 times cosecant x. So my answer is 2 cosecant x. Okay? That one was pretty intense. We went from that, getting a common denominator, FOILing, combining like terms, all the way down to where we get 2 cosecant x. Some of these are going to be kind of complex, but as I said, I think they're quite fun because you've got just kind of a creativity in here where you could try different things. If you get to a point and it's stuck, it's not working, go back, try it again, or try something a little bit different. You never know what will work out. Okay, we're going to do this next one. And what I would suggest on all of these videos is actually try it yourself. Pause the video, give it a try, see if you come up with a solution, and then watch the video, see how I do it. If you get the same answer but you did it a different way, you're probably just fine. You probably did it correctly. great. If not, then look at how I did it and maybe you'll get an idea of what you did wrong. Okay, so there we go. This video is the one's a little bit longer, but that's okay. We're going to get a common denominator. So this is cosecant x plus or minus 1. Cosecant x minus 1. This one we'll do cosecant x plus 1. Cosecant x plus 1. Okay, so I have 1 over, and I'm going to FOIL this. This would be cosecant squared x minus 1 minus this should be cosecant x plus 1 cosecant x minus 1 over cosecant squared x minus 1. Okay, if you notice these are difference of squares, that's why I did a little shortcut and I didn't have to multiply it out and simplify. And that red is not working for me. Let's see if I find a different one. Okay, so now I have cosecant x plus 1 minus cosecant x minus 1 all over cosecant squared x minus 1. Okay, that minus is still there. We got to distribute that through. So I have cosecant x plus 1 minus cosecant x plus 1. Okay, we distributed that through. So those are going to cancel out. We get 2 divided by, and I'm going to check cosecant squared x minus 1. That might be a Pythagorean identity. Ooh, I have 1 plus cotangent squared theta equals cosecant squared theta. That's close. If I take that 1 and subtract it over, I'd get cotangent squared theta equals cosecant squared theta minus 1. So this right here equals cotangent squared x. So cotangent squared x. Okay, so that is looking pretty good. Let's see if we could do anything with that. So cotangent squared x. Well, that's the same thing as 2 times 1 over cotangent squared x. And we know 1 over cotangent, that should be the same thing as tangent. So this is 2 tangent squared x simplified. Okay, so usually when we simplify, if we could get rid of that fraction by using the reciprocal identities, we are going to do that. Okay, I've got 3 more examples and we'll do those on the next videos.